Hello guys and welcome to this video. In this video we are going to discuss the white paper of Blender network. So let's quickly get started with the same. So this is the white paper of the Blender network. So let's quickly go through it. By the way, the price of Blender network is nearly 30% up today, and couple of days back it was also trending on CoinGecko in the top 3 coins or something. So I thought that I should make a video about it. So let's quickly get started with the white paper. In the rapidly evolving landscape of GPU computing, the demand for accessible, cost effective, and scalable computing power is more critical than ever, especially in fields like artificial intelligence and content rendering. Blender introduces a groundbreaking decentralized network that leverages the idle GPU resources across the globe, offering businesses and individuals unparalleled access to high performance computing capabilities. The technical paper presents Blender's innovative approach to decentralization, utilizing blockchain technology to create a marketplace for GPU computing power, thereby addressing the limitations of traditional centralized infrastructures. By harnessing underutilized resources, Blender not only maximizes efficiency and reduces costs but also democratizes access to cutting edge computing power, paving the way for advancements in AI and digital content creations. So basically, what they are trying to do here is that they will use the processing power of computers and they will allocate it to big companies or people who need heavy or high computing processing power to process high quality digital stuff, I guess. So that is what the core concept is. Let's move forward. Key features of Blender, including its scalability, cost efficiency, and novel use of Blender token to facilitate transactions within the network, are discussed, highlighting the performance potential to transform the GPU computing industry. So they want to transform the computing industry. Introduction. The advent of GPU intensive applications in AI research, 3D rendering, and complex simulations has led to a surge in demand for high performance computing resources. Traditionally, organizations have relied on centralized GPU farms or cloud services, which often come with high costs, limited scalability, and concerns over data privacy and security. Moreover, the centralized nature of these services results in underutilization of resources as GPUs often remain idle outside peak usage time. Objective: Blender aims to revolutionize the GPU computing domain by establishing a decentralized network that aggregates idle GPU power from contributors worldwide. This initiative seeks to offer an on-demand, scalable, and cost-effective computing resource pool to businesses and researchers, thereby accelerating computation intensive tasks while optimizing the utilization of existing resources. Significance: the significance of decentralizing GPU computing infrastructures lies in its potential to overcome the barriers of traditional models such as high costs and scalability constraints. By enabling a more efficient allocation of resources, Blender tends to enhance the reliability and performance of computing tasks, foster innovation in AI and rendering projects, and promote a more inclusive and accessible computing environment. So generally rendering is an area where one needs very high amount of computing power. So I guess that's the reason why they are mentioning the rendering part very much more uh, again and again in the white paper. Now system overview. Blender's architecture is designed to facilitate a seamless, efficient, and secure decentralized computing environment. This section outlines the high-level structures of the network, including its main components and their interactions, providing a foundational understanding of how Blender operates. The Blender network is composed of several key components, each serving a distinct role within the ecosystem. Node Manager acts as the central authority for the network, managing user requests, job submissions, and the overall health of GPU nodes. Task Scheduler, responsible for allocating computing tasks to available GPU nodes, ensuring efficient distribution based on the network's current load and node capabilities. GPU nodes, the backbone of the network. These nodes execute the computing task assigned by the task scheduler, utilizing idle GPU resources from contributors worldwide. So whoever is giving the computing power to them, the task scheduler will utilize that and allocate it to the companies or the people who need it. Data storage, a secure a repository for storing task related data, including input files, configurations, and results, ensuring data integrity and availability. System overview, workflow, task submission. Users submit computing tasks to the network via the node manager, specifying requirements and priorities. Task allocation, the task scheduler assesses the network's capacity and assigns tasks to GPU nodes based on their availability and the task execution. GPU nodes execute the tasks leveraging their GPU resources. Again, the same concept is mentioned. Progress and the status updates are communicated back to the node manager. Result storage retrieval. Upon completion, the results are stored in the data storage component and made available for retrieval by the users. Decentralization. Decentralization is achieved through the distributed nature of GPU nodes and the blockchain powered marketplace. This so there will be a marketplace which will be backed by blockchain technology, where the GPU powers allocated by the different uh, people all over the globe will it will be allocated to the people who need it, so that that marketplace will be also blockchain powered marketplace. At least that's what my understanding is. And again, let me be clear that nothing in this video is an investment advice, so do your own research before investing in any cryptocurrency projects. This structure ensures resilience against failures and optimizes a resources utilization across the network. Blockchain technology facilitates secure transactions, enabling users to rent GPU power and contributors to earn Blender tokens, further incentivizing participation in the network. So whoever provides the GPU power will have the Blender token as the rewards. Key components and technologies. Node manager. The node manager serves as the operational hub of the Blender network, orchestrating interactions between users, tasks, and GPU nodes. It ensures the network runs smoothly, managing user requests, authenticating participants, and monitoring the health and performance of GPU nodes. Functionalities. Network management oversees the entire network, ensuring efficient operation and resource allocation. User request handling processes user submissions, including task requests and configurations. Authentication and authorization validates the identity of users and nodes, enforcing security protocols and access controls. Node health monitoring continuously assesses the status of GPU nodes, facilitating maintenance and troubleshooting to minimize downtime. Key component and technologies. User interface provides a web-based or command line interface for users to interact with the system, submit tasks, and manage their accounts. Authentication module implements secure measures to authenticate users and nodes using techniques like digital signatures and two-factor authentication. Node Monitor, a monitoring system that tracks the performance of status of GPU nodes, alerting the node manager to any issue or downtime. Communication module facilitates communication between the node manager, GPU nodes, and users, ensuring secure and efficient data exchange. Key component and technologies task scheduler. So this is the entire chart. Progress tracker updates the task submission. Task submission keeps the task in the queue. And Sorry for this disturbance. Task queue, load balancer, then it moves to the scheduler algorithm, and then to task allocation and to error handler. So this is the chart. You can go through it if you want to understand, although I have helped you understand what the project and the core concept of the project is all about. Again, functionalities, task allocation assigns tasks to GPU nodes, taking into account the requirements of the task and the available resources. Priority management handles task priorities and dependencies, ensuring critical tasks are processed in a timely manner. Progress monitoring and error handling tracks the progress of tasks and manages any error or failures. Implementing retries or reallocating tasks as necessary. Components, task queue, a dynamic queue that stores pending tasks, organizing them based on priority and requirements. Load balancer distributes tasks among GPU nodes to prevent overloading and to ensure an equitable distribution of work. A set of algorithms that determines the optimal allocation of tasks, considering factors such as node performance, task complexity, and network conditions. Progress tracker monitors ongoing tasks, providing real-time updates on their status to users. And the node manager, error handler, identifies and manages task failures, implementing strategies for retry or reallocation to other nodes. GPU nodes. GPU nodes are at the heart of Blender's computing power, executing tasks allocated by task scheduler and utilizing a GPU resources efficiently. Task execution performs computing tasks using GPU resources following instructions from the task scheduler. Status reporting regularly updates the node manager on its of availability, health, and task progress. Resource management manages GPU resources to optimize performance and energy consumption. Security implements robust security measures to protect against unauthorized access and ensure the integrity of task data. Key components and technologies. Rendering engine, the core component that executes rendering or computation task using the GPU's capabilities. Node agent, a software agent that communicates with the node manager and task scheduler, relaying status updates and receiving task assignments. GPU resource manager monitors and manages the allocation of GPU resources to tasks and ensuring efficient utilization. Security module provides a suite of security features including encryption, access controls, and intrusion detection. Key components and technology. Again, you can go through the data storage chart to understand it more efficiently. We are going to quickly move forward because the video is becoming a bit lengthy already. As you can see here, it shows 14 minutes of recording has been done and there are still a few pages left out. So we'll quickly go. Functionalities, data durability and availability ensures that all stored data remains intact and accessible even in the event of hardware failures or network issues. Security protects stored data from unauthorized access and tampering, employing encryption and access control mechanism. Database stores critical metadata, user information, and configuration settings, facilitating efficient retrieval and management of task-related data. File storage, a scalable storage solution for input files, textures, and rendering results, supporting a variety of file formats and sizes. Blockchain integration, the integration of blockchain technology is a cornerstone of the Blender network, facilitating a transparent, secure, and efficient marketplace for GPU computing power. This section delves into into how blockchain enables the decentralized operation of Blender, focusing on the marketplace mechanics and the tokenomics of Blender tokens. Key component and technologies. The blockchain-powered marketplace operates at the heart of Blender, enabling users to rent GPU computing power from node contributors around the world. This decentralization approach not only ensures transparency and security in transactions, but also allows for the efficient distribution of computing tasks across the network. Smart contracts. Transactions within the marketplace are governed by smart contracts which automatically execute agreements between users and node contributors based on predefined conditions. This eliminates the need for intermediaries, reducing costs and enhancing trust. Decentralized ledger. The blockchain serves as a decentralized ledger recording all transaction interactions within the network. This transparency ensures that the users and contributors can verify transactions, contributing to a secure and trustworthy ecosystem. Token based transactions. Access to GPU computing resources and rewards for contributors are managed through Blender tokens, the native cryptocurrency of the Blender network. This facilitates seamless, borderless transactions and incentivizes participation in the ecosystem. Tokenomics. Blender tokens play a pivotal. Okay, let's quickly move to earning rewards. Contributors who make their idle GPU resources available to the network are rewarded with Blender tokens. This reward mechanism encourages the growth of the network's computing power, directly benefiting all the users. Paying for resources. Users requiring GPU computing power can pay for access using Blender tokens. The cost effectiveness of this model compared to traditional centralized computing services make high performance computing accessible to a broader audience. Staking for governance. Blender tokens also serve a governance function, allowing token holders to participate in decision making processes regarding the development and operation of the network. This fosters a community driven approach to managing the Blender ecosystem. Security considerations. Ensuring the security of the Blender network and its participants' data is paramount. This section outlines the key security measures implemented to protect against unauthorized access, data breaches, and other cyber threats. All data transmitted within the Blender network, including task submissions, results, and communications, is encrypted using advanced cryptographic techniques. This protects sensitive information from interception and unauthorized access. Robust authentication mechanisms verify the identity of user and nodes, preventing unauthorized entities from accessing the network. Authorization protocols ensure that participants have appropriate permissions for their actions, safeguarding against malicious activities. Node security. Individual GPU nodes implement security measures to protect against external attacks and unauthorized access to computing resources. This includes firewalls, intrusion detection system, and regular security audits. Given the critical role of smart contracts in the marketplace, rigorous testing and auditing processes are employed to identify and rectify vulnerabilities, ensuring the integrity of transactions within the network. Scalable performance. A key advantage of Blender's decentralized architecture is its inherent scalability, capable of accommodating the growing demand for GPU computing power without compromising performance. The network's design allows for the flexible and dynamic allocation of GPU resources, efficiently distributing computing tasks based on current demand and node availability. This scalability ensures that Blender can support a wide range of applications from AI training models to complex 3D renderings. Uh, Through the use of advanced scheduling algorithms and load balancing techniques, Blender maximizes the utilization of available resources, reducing wait times and accelerating task completion. Continuous monitoring and optimization efforts aim to enhance the network's overall performance, ensuring users benefit from rapid and reliable computing services. The implementation of Blender involves a structured approach to developing and deploying the decentralized GPU computing network. This plan outlines the phases of development, key milestone, and the technology stack that will be utilized to bring the Blender to life. Technology stack: Blender blockchain platform, Ethereum for its robust smart contract capabilities. So they are going to have Ethereum as their uh, network. Smart contract solidity programming language for creating the smart contracts that govern transactions and interactions within the marketplaces. Node communications, peer-to-peer network protocols such as libp2p to facilitate efficient and secure communication between the nodes. Data encryption and security, AES advanced encryption standard for data encryption along with SSL TLS protocols for secure data transmissions. Backend and API development, Node.js and Express.js for scalable server side applications, providing APIs for users and node interactions. Front end development, React for building a dynamic and responsive user interface for the web based node manager and user dashboard. Database management, MongoDB for flexible, scalable data storage of user information, task metadata, and transaction records. Conceptualizations and design define the system architecture and component significant. Sorry, component specifications. Sorry, I looked at my phone, so that's why I was not properly reading it. Design the smart contracts and tokenomics model for Blender tokens, prototype the user interface and experience, code development and the test the smart contracts on the Ethereum testnet, implement the node manager, task scheduler, and GPU nodes, integrating the necessary security and communication protocols, establishing the data storage infrastructure, ensuring robustness and security, network testing and optimization. Deploy the system on a test network to simulate real world operations. Conduct extensive testing to identify and rectify security vulnerabilities, performance bottlenecks, and usability issues. Optimize task scheduling algorithms and load balancing techniques for improved efficiency and performance. Mainnet launch and expansion. Launch Blender on the Ethereum mainnet, opening the network to public users and contributors. Monitor network performance and user feedback, making necessary adjustment and enhancements. Expand the network by attracting more users, contributors, scaling the infrastructure as needed to accommodate growth. Continuous improvement in governance. Implement governance mechanism allowing token holders to influence the development and operation of the network. Continue refining and adding features based on community feedback and technological advancement. foster a vibrant ecosystem around Blender, encouraging innovation and collaboration within the decentralized GPU computing space. Conclusion: Blender represents a paradigm shift in the landscape of GPU computing, harnessing the power of decentralization to unlock unprecedented accessibility, efficiency, and scalability. By leveraging idle GPU resources across a global network, Blender democratizes high performance computing, enabling advancements in AI content rendering and beyond. The integration of blockchain technology ensures a transparent, secure, and fair marketplace, while the innovative use of Blender tokens incentivizes participation and facilitates seamless transactions. With robust security measures and a scalable architecture, Blender is poised to meet the evolving demands of the computing world, fostering collaboration and innovation. As we embark on the journey to realize the vision of Blender, the commitment to continuous improvement, community engagement, and technological excellence will guide the network's growth and success. Join us in shaping the future. Okay, so that's all I have for the Blender white paper. I hope you enjoyed the video. And again, nothing in this video is an investment advice. I just almost in the major part of the video, I read out the entire white paper, and apart from that, I think there are many projects like that out there. So uh, like iExcel is an older project. IEXEC, I think that's the spelling. And apart from that, I also made a video on OPSEC, which is also a project with similar concept. So yeah, if you enjoyed the video and if you want to join my Telegram community, then I will put the link in the description. And if you enjoyed the video, then I appreciate if you like the video and subscribe to the channel. I will see you in the next video, and till then, take care. Bye bye.